All right. Let's begin with these exercises. 7F. Now, I feel like we should begin with the first one, right? And then maybe jump into another one, maybe jump into the fourth one, the last one, right? So most of these books usually present exercises changing the difficulty from the lowest difficulty, right, the easiest, to the hardest. So I'm thinking maybe let's just do the easiest first, right, so that we can get the hang of the topic, and then we'll do the hardest, right, and we'll see that maybe this is not that hard. All right, so number one, this one. Number one, a fair what? A fair decahedral die, number 1, 2, 3, well, all the way till 10, is thrown and the number is noted. All right. Now we're going to have two events. Number one, the event A, throw a square number, right? That is the event A, throw a square number. The event B, throw a factor of 6. All right. So we have our two events, A and B. An example of event A. An example of event A will be getting a 2. No. A 2 is not a square number, so no, 2 is not a good example of event A. Remember, square numbers are numbers that are results of elevating to the second power another number. So for example, 4, 9, 25, 16, 49, right? All of those are 2 to the second power, 3 to the second power, 4 to the second power, 5 to the second power, right? Those are square numbers. Now, an example of event B, a factor of 6. What is that? A factor of 6. Okay, so maybe 6 is a good example, right? 6 is a factor of 6. What is factor, guys? What is factor? Well, factor is a number that can divide 6, right? In this case, a factor of 6 is a number that can divide 6. So the possible factors of the number 6 are 1, 2, 3, and 6. Because only those 4 numbers can divide this number 6 without having decimals, right? I know, come on. I know if I do 6 divided by 5, if I do that, I'm going to have decimals, right? So that is not a good example. 5 is not a factor of 6. I need to have a clean division, 6 divided by 2, that's a clean division. That's 3. No decimals, right? So 2 is a factor, right? Cool. So in event B, we have 4 numbers, right? Okay. Now, the exercise says that we have our Venn diagram here, this Venn diagram. Give me just 1 second. Somebody's speaking outside with a loud microphone. Please go away. What's going on? I don't know if you guys can hear that. Can you tell me, guys? Can you let me know? Can you hear that?
No.
All right, cool. All right. Whoosh. Was a guy speaking so loud with a microphone outside. All right. So we have our Venn diagram, right? And in this Venn diagram, we have this information presented. So we have the events A and the events B, right? So here is the event A. Every circle of the event A are the possibilities, right? So we have 4, that's a square number, right? 9, that's another square number. And 1, that's another square number. Also, for event B, in the circle of event B, we have the possibilities, right? So our factors of 6, remember, event B is throwing a factor of 6. So 1 is a factor of 6. 2 is a factor of 6. 3 is a factor of 6. 6 is a factor of 6. All right, so those are our possibilities. Outside those two circles, outside the circles, we have the rest of the values that are not in A or in B. So the values that are not square numbers, and also the ones that are not factors of 6. Remember, the possible numbers are from 1 to 10, right? These are the possible numbers. We are throwing a decahedral die. So from 1 to 10, right? Okay, Cool. Now let's find let's get to our questions so that we can find the solutions. Number one, find P of A. Do you guys remember what is this? What is P of A? Tell me, guys. Do you remember that? Guys. Anybody? Anybody now? Okay, Majo says no. Cool. Nobody? Really? You have no idea what is this?
No.
Okay. All right, we're gonna do our solutions here. So A. Somebody said something here in the chat. They are any of the numbers in the A circles. You get the idea, brother. You get the idea. You get the idea. All right. So what we have here is this P of A. This is in mathematics the probability of the event A. This is regular notation, guys. You should know this by now. You should know this by now. This is the probability of the event A. Right? Probability of the event A. So how do we find that? How do we find that? Simple. We know that all probabilities have a success over a total. A success over a total. The total is the entire amount of possibilities that we have. And we know we have 10 possibilities, right? The numbers from 1 to 10. So the denominator of our probability is 10. What goes up? Well, up is the success. In other words, the events, the possibilities that are in this event. And in that event, we have 1 possibility, 2 possibilities, 3 possibilities. Look at that. Every single possibility inside the circle A. So 3 possibilities. There we go. We finished. That's it. That's it, guys. How much is P of A? The probability of the event A. 3 over 10. All right? Let's go with P of B. P of B. What is P of B? Well, this is the probability of the event B happening, right? What is the probability of the event B? Talking about this one here, right? Probability of the event B is, again, a success over a total. It's a fractionary, right? The total is the same. We have 10 possibilities. 1, 2, 3, 4, 5. These are the possible numbers that we get when we throw the die. So we got 10 possibilities. That's the total, right? And how many of those 10 possibilities are successful for us? Well, the ones of our event. How many, guys? Please tell me in the chat. How many possibilities are successful for us? Right here.
4.
4.
Cool. Thank you. 4. 1, 2, 3, and 4. Beautiful. There it is. 4 over 10. So far, so good. Now, I'm assuming you guys maybe, I don't know, maybe you guys have a lot of things in your mind, right? Or maybe you knew the topic, but you didn't remember what was this notation. I'm going to assume that, all right? I'm going to assume that. Because this is absolutely easy. There shouldn't be a reason why you don't know this, right? There shouldn't be a reason. All right. So I'm going to assume maybe you did knew this. Maybe you just forgot about the notation, right? So let's work on these now. What is the probability of A intersection B? This is how this is written. This is how you read this. This is how you read this. Probability of A intersection B. So what they are asking us here is to find the probability that both events happen at the same time. So that in our success, I'm going to write every single number that is both a square number and also a multiple of 6. That is the idea behind this little sign over here. This little sign implies AND. So I want A and B. That's what I want. A and B. I want numbers that are A and B at the same time. And in our example, we only have one. This one. Look at this. This value is in the middle of A and B. This is the circle for A, right? And here with red, this is the circle for B. And right in the middle of those two, we have this section here. Every single value in this section belongs to A and also belongs to B, right? The one is a square number, that's A, and the one also is a multiple of 6, that's the B. So our success here is only one possibility. In other words, what is our probability? In the chat, please, everybody, in the chat. What is our probability? I'm going to help you with this. 1 over what? 1 over what, guys? Come on. Everybody in the chat, please. Everybody. All right. Thank you, guys. Beautiful. Thanks to all of you who are actually participating. Beautiful. 1 over 10. Again, the idea behind probabilities is always and will always continue to be the successful ones over the total. That is the idea of a probability, the successful one over the total. Success is only one possibility, total are 10. All right? All right. Let's continue with the last one. This one. Probability of A union B. That is how you read this thing. You don't say A and B. No. You don't say A, U, B. No. You say A intersection B and A union B. Those two little signs have names, right? So we need to use those. Now, in this case, what is this little sign? The U, the union. What is that? That means or. So we are looking for values that are maybe square values, right? Square numbers. Or maybe they are factors of 6, right? Now, here's a big deal in mathematics. This or doesn't exclude one of the other. Let me explain this better. Whenever you find this or, I don't mean is either A or is either B. I don't mean that, right? So, for example, if I pick a value that is A, that doesn't mean that automatically it cannot be B. No. This or also carries the possibility that the value I pick is both. So I can pick a value that is square number, or maybe is a factor of 6, or maybe is both. Remember this here, this is both, right? This is the intersection, this is both. Right? So let's take a look at our probability. Again, the easiest is the denominator. This is 10. But how many are the successful ones? Out of these 10, how many of those are a square number, or a multiple of 6, or both? Well, let's take a look at those. Here, this is a multiple of, that is a square number. Also a square number, right? So I'm counting 2. Also this one. This 2, this value 2, right? That is a factor of 6, right? Also this one over here, factor of 6. Also this one over here, factor of 6. All right? But remember, the or also takes into account the possibility of having both. And both is the intersection. This one here is being both, right? The one is a square number and a factor of 6. So in this case, our success, just like everybody in the chat, or well, some people in the chat are saying, is 6. That is our success. So the probability in this case, we can simplify this. This will be 3 over 5. We can also do this in here, right? So this is 2 over 5. All right. Pretty good, guys. Pretty good. Pretty good. All right. That is how you find these probabilities. Let's jump into question B. I'm going to do B here, right? Hence, momentico en español. Este hence es muy importante que sepan cómo usarlo. Para la IB, hence significa con base a lo anterior. Eso significa hence. Si tú resuelves la pregunta sin hacer uso de lo anterior, no estás respondiendo a la pregunta de manera adecuada. Aquí podría decir, show that, lo que sea. El resto de la pregunta, quita este hence. Ahí podría decir eso. Pero no lo dice. Dice hence. tienes que usar lo anterior. Ojo a eso, mi niño, ¿listo? No se trata solo de responder esta pregunta. No se trata solo de responder esta pregunta. No, no, no. Se trata de usar la pregunta usando hence. O sea, usando lo anterior. All right, let's continue in English now. So hence, show that this thing over here is equal to this other thing over here. Right? That is what we need to show, right? We need to show that the thing to the left of the equality is also the thing to the right of the equality. So the easiest way for us to do this is to replace with the values that we know. We know this. We know it. It's right here. Look, it's right here. Right? In fact, we know each of these. We know P of A is right here. P of B, we know it, right? P of A intersection B is right here. We know that. We know that. So we are going to show that, in fact, those two things are equal. All right, let's begin with the first one, right? So if I replace this, right? P of A union B, right, has to be equal to P of A. What I'm doing here is just copying the same question, right? The same, how do you call this thing? I forgot the name. The same operation here that I had to replace. Expression, the same expression. I'm just copying down the expression. Probability of B minus probability of A intersection B. There it is. All right. Let's replace this thing over here. So on the first, on the left side, we have the union, right? So that is this, 3 over 5. So I'm just gonna do it here, 3 over 5. All right. To the right, what do I have? To the right, I have P of A. P of A is 3 over 10. Plus P of B, which is 2 over 5. Minus the probability of the intersection, right, which is 1 over 10. All right? Now, if I want to show this is correct, right, the thing to the left is the same as the thing to the right, if I want to show that, all I have to do is do the operations, right? I just have to solve this addition and this subtraction of fractionaries here, right? Hopefully, you guys remember how to do this, right? Let me just amplify this fraction a little bit so that the denominator is 10 as well. So I'm going to multiply by 2 up and down, right? If I do that, the new denominator will be 10. And up, I'll have 4. In other words, I just went back. And now I have this answer, 4 over 10. All right. Now, what is the result here? Scroll down a little bit. What is the result here? All right, so this is 3 over 10 plus 4 over 10 minus 1 over 10, right? Let's do that operation. So if I do the first two, or I can just do them all at the same time, right? They all three have the same denominator. So I can just leave the denominator and add or subtract the numerators, right? So 3 plus 4 minus 1. How much is this? How much is this? How much is this? All right, so this is 7 minus 1, right? So that is 6. 6 over 10. But look at that. 6 over 10 can be simplified, right? 6 over 10, yes, it's exactly 3 over 5. Which is exactly the first part. Look at that. Look at that. By using what we knew, we showed this little formula over here. Cool. All right, this is how you do it, guys. All right. Question C, I don't have enough space to do question C in this side, so I'm just going to do it in this corner. I'm just going to do question C in this corner, all right? Here, C. State with a reason whether events A and B are mutually exclusive. Mutually exclusive. What is this, guys? What is this? You were reading this information before, right? You were reading this. So tell me in the chat, please. Tell me. What is this? What is the meaning of this? How do you know when two events are mutually exclusive?
Mister, I don't know if I'm correct, but I'm going to say.
Sure, cool.
Is B, paréntesis, A and B, paréntesis, cierras, equals 0.
Like this?
Yes.
All right, cool, beautiful. You got it. All right, sure. So two events, A and B, are mutually exclusive if the probability of the intersection is 0. That is correct. That is correct. That is correct. Yes, that is correct. The probability of the intersection is 0. Cool. A lot of people are writing that down in the chat. So guys, pretty good job. Pretty good job. Now, we can expand on this a little bit better. We can expand on this. Now, what is that? What is the idea behind the intersection being 0? The probability, sorry. The probability can only be 0 if the set itself is empty. Look at this. In this case, the event, the set, right? This is the set. This little part over here, the part in blue, that is the set A intersection B. And it is not empty. It has a 1. There's something there. Right? So the probability of that set happening, of A intersection B happening, is not 0. No, it's something. Look at that. We have it here. Probability of the intersection. Right here is something. It's not 0. It's something. Right? So just because of that reason, just because either the first one, right, the probability is not 0, or the second one, the event, the set is not empty. Any of these two are good reasons to show that the events are not mutually exclusive. Let me just write it here. A and B are not mutually exclusive. Sorry about that, guys. Takes a lot of effort to write using a mouse. I'm sorry, guys. So yeah, A and B are not mutually exclusive. Why? Well, because of this, the intersection is not 0. Let me write it here. Is not 0. It's not 0. The intersection is not 0. Or maybe this other. The set is not empty. Set is not empty, right? In fact, the probability of A intersection B is 1/10. We know that right here. We know that, right? We know that. It's not 0. That is the reason. That's it. Now, in other words, if you want to put this instead of having mathematics, right? Instead of writing this down as mathematics, if you want to put the idea behind mutually exclusiveness using just words, how would you do it? I would do it like this. Two events are mutually exclusive if there is not an element, right? Or if they both cannot happen at the same time. That's what I would say. Two events are mutually exclusive if they both cannot happen at the same time. In this case, both events can happen at the same time because we have a 1. If we draw 1, then we got event A, and also event B at the same time. All right? Cool. This is question A, question 1 for you guys. All right. Question 1 for you. Beautiful. All right. Do you guys have any questions about this? Or can we jump into the question number 4? Tell me, guys. Please, tell me. Nope? All right, cool.
Can you stop your screen, please?
Can you what? Karin, what?
Yes, scroll down like a little bit. Yeah. Thank you.
You're welcome, Karin. All right, so let's jump into question number 4. This one is going to be a little bit more interesting. I haven't read this. I haven't read this question at all. So I feel like this is going to be really interesting just because of that fact. I am not prepared for this. Let's see. Let's see how this goes. All right. So Finn explores the ages of people in his family, right? He represents his family's ages with the set U. All right, so we have the set U. Now, these are going to be the ages of his families, right? So he has 2, 3, 4, 6, 8, 9, 10, 12. These are the ages, right? These are the ages. So apparently he asked, or he went around the family and he has a couple of kids, right? A couple of babies in the family, right? I would assume this is babies, right? He has a couple of kids. Maybe these are kids, right? A couple of teenagers, right? Teenagers. And then some adults, right? Okay, cool. Now, let's jump into the question. A, draw U and each of the following sets on the Venn diagram. Now, what is U? As you can see here, in the second example and maybe in the first example, U is this one. Sorry. Here, there. That is U. It also appears here. Usually in a corner, the corner is showing that U makes a reference to the whole diagram, to the whole rectangle. The whole rectangle. So here, for example, here we have 3 sets. A is one, B is the second one, and U is the third. 3 sets, which is why we have 3 geometrical figures. We have one circle, another circle or ellipse, whatever, and then we have the rectangle. All right? The rectangle is known as the universal set. When they ask us to draw U, they are asking us to draw the universal set. So we are going to begin with this. There it is. We did it. I have the universe. I can do the U inside or outside. Doesn't really matter. All right? Now, we also need to draw each of the following sets in the Venn diagram. A, B, C, D. You have those 4. So I'm thinking I'm not going to have enough space, so let's just erase that square. Let's do the circles first, and then we'll close that circle with our rectangle. We'll close those circles with our rectangle. All right, so let's do event A. Let me erase all of these. Erase all of these. Beautiful. Let's focus our attention on the first one. A are the even numbers. What are the even numbers? I'm going to do it here. What are the even numbers? Again, the even numbers from these sets, right? So you have 2, 4, 6, 8. All right, so 2, 4, 6, 8, 10, right? 12, 14, 16, and I don't have enough space now. All right, what else? 16. That was it. That was it. No more numbers. All right, this is event A. Cool. We're done. We are done, right? Out of the possible numbers, these are the only ones that are even. Los pares. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, right? 12, 14, 16. 12, 14, 16, and that's it. Yeah. All right, we did it. Cool. We did it. Let's jump into the second part. B, multiples of 3. All right. So multiples of 3 again. A circle here for B. And I'm going to write down the multiples of 3. So what are the multiples of 3? The results of multiplying 3 times something. That something has to be natural, right? So 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, and so on. 3 is a multiple. 6 is another multiple. 9 is another multiple. 12, 15, right? I think that's it, right? 25, 35, 65. Yeah, that's it. So we have 3, 6, 9, 12, and 15. All right, we did it. Guys, if I have to do this exercise and finish it here, only by doing these 2, A and B. Only by doing these 2, A and B. So forget about C, forget about D. All right, forget about those. If I only had to do A and B, so even numbers and prime and multiples of 3, I'm gonna ask you something and I want you to answer, please. Is this correct?
No,
No.
Cool. Why not?
because 6 and 12 is in both.
Beautiful. Yes, Mafe, beautiful. We have some elements on the blue, on the set A, and some elements on the set B that repeats, right? So for example, look, the ones that Mafe are saying. 6 is here and it is also there. 12 is here and it is also there. These are values that are both multiples of 3 and prime numbers. What that means is that I have to rethink this organization. I have to rethink this organization. Because these two sets have to be organized like this, with a possible space for them to overlap. And we know that space have these two values, 6 and 12. Right? This is set A, this is set B. Now, I'm just going to write the rest of the numbers here. So we have 2 even numbers, right? So 2, 4, 6. 6 is already there, right? 8, 10, 12, 14, 16. All right. And in the multiples of 3 part, right? In the set B, we have 3, 6, 9, 12, 15. Beautiful. All right. Now, this is a good diagram. If we were to finish only with A and B. We have a couple more prime numbers. We have a couple more prime numbers. What are the prime numbers? Here, in this set. Which of these are prime numbers? Okay, so I know 2 is a prime number. 3 is a prime number. All the evens, outside of 2, of course, outside of 2, all the even numbers are not prime numbers, right? So, no. All right. All the multiples of 3 are not prime numbers, of course, except with number 3. So, not the 9, not the 12, not the 15. All right. 25 also no. 35 is 7 times 5, so no. 55 is 5 times 11, so no. 65 is, how much is 65 a prime number or not, guys?
No,
Okay, cool. Why not? Mafe, was that you? Who said no? Who said no? I need the person to tell me why not. All right, I'll explain it. Because it finishes in 5, right? The last digit is 5.
5 por 13, ¿no?
Yep, 5 times 13, yeah. And also because the last digit is 5. So if the last digit is 5, that means it is divisible by 5. You can divide 65 by 5. It is 13, right? So the only 2 prime numbers that we can write in our circle C are the value 2 and the value 3. This is for C. But again, look at this. 2 appears here and 3 appears there. So what do we do? What do we do, guys? We're going to have to erase all of this again. I'm going to have to erase all of this. What if I do circle C like this? Huh? And now in the middle here in this part, I am going to write the ones that are prime and even. So with black, here is the number 2, but I cannot have it repeated, right? So I'm just going to erase it here. There it is. This is C. And for this one, I'm going to write the 3 here, but I cannot have it up there. So there it is. I know. there. All right. Question, do I write something here? Do I write something in there? Yes or no?
No,
Okay, why not, Paul?
because there is not an union between A, B, and C.
Cool. Intersection, Paul. But yeah, you get the
Intersection.
idea. We don't have an intersection. There is not a number that is even, multiple of 3, and prime number at the same time. That number doesn't exist. So I know, what did I do? So that number, that sector, sorry, is gonna have to go empty. There it is. That sector will go empty. All right, beautiful. We got our C now. Let's do the circle for the event D. Numbers greater than 30. Greater than 30, guys. Numbers greater than 30. All right. I'm just going to do a little circle over here. And just like we did in all our example, after we do this circle and we fill it in with the values, we're going to take a look and see how many of those actually overlap with the ones that we have. And that is how we're going to locate the circle, right? All right, so bigger than 30. Bigger than 30. How many are bigger than 30? Have this one, and this one. All of these 3 are greater than 30, right? So let me just write them down. 35, 55, and the last 65. All right, guys, did we finish? Is there any value in the set D? I forgot about putting the name there. Is there any value in the set D that is repeated in A, B, or C?
No.
Looks like not, right? Doesn't look like it. Let me raise that 4 and this 0. Let me just do this a little bit cleaner. This is a 0 and this is a 4. All right. No, right? So we don't have the values 35, 55, or 65 before. We didn't have those values before. All right. So we don't have to connect this circle with any of the other 3. Beautiful. Let's just do the little rectangle for the universe. And that will be it, guys. That will be it, right? That will be it. We are done, right? We got a 7 in our quiz, right? Are we missing something? Is this correct? Lily, tell me. Lily? Okay. Guys, I'm going to ask again. Is this diagram correct?
No,
Okay, Lily. Why not?
because 25, as is not in the 4 groups, it needs to go outside.
Yes, Lily, beautiful. And beautifully explained also. Look, we need to make sure that every single value of the set U is here in the set U. Every single digit. And we have the 2. Is there. We have the 3. Right? I'm just gonna highlight them here in the question. We have the 4, the 6, the 8, the 9, the 10, 12, 14, right? We have the 15 is right there. We have the 16, and then the bigger than 30s. We don't have the 25. It says here that it belongs to the set U, but it is not here. It is not in any of the circles, which means we need to put it outside of any of the circles. Now, where? I don't know. You can put it here, 25. Or maybe you can put it there, 25. In any position, to be honest. It just the only thing that matters is that you put it outside of the circles, and of course, you don't repeat it, all right? You're not going to put it twice or 3 times. No, just put it once. There it is. Now we are done. Now we finish the question A. This was question A. All right, our Venn diagram. Of course, yours should look a lot better than mine, a lot cleaner than mine. Because look, I just did this with my mouse in my hand, so Yeah, looks awful. If you use something to draw circles, it's gonna look a lot easier, a lot cleaner. All right. All right. Let's erase this. Blah, 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 blah. And let's jump into question B. I think I can do question B here. B. All right. Finn chooses a family member at random. All right. Use your diagram to determine which, if any, of A, B, C, or D can form a mutually exclusive pair of events. All right. So we need to select the sets that are mutually exclusive. Those are the ones that we need to select. Remember, what is the idea behind mutually exclusiveness? Anybody, please tell me. How do you know if two events? Uh-huh. Yeah, you got it. You got it. Say it again, Mafe. Say it again, please.
That it has to be 0.
The probability has to be 0. Yes. Or the space, the set, the little intersection is empty. Little intersection is empty. Doesn't exist. Right? Okay. So in blue, tell me, are these two mutually exclusive? In the chat, tell me yes or no. Everybody, please. Everybody in the chat. Everybody. Tell me, are those mutually exclusive or not? Okay, cool. Thank you. Most people are saying no. Why not? Well, because the intersection is this one. This little part is the intersection. And as we can see, there is something there. We need to have intersections that are empty. And this one has things in it. So this is not a good example of two sets that are mutually exclusive. Let's go with, yes, sir.
Tengo una pregunta.
Yes, sir.
Digamos, en el caso del D, o sea, no tenemos intersección con los otros.
Okay.
Entonces, ¿cómo podríamos mirar si es mutually exclusive?
Paul, that's a great question. That's a great question, Paul.
O sea, ¿no tendríamos que tener intersección con todos?
Paul, you are correct. That is a great question because at first sight, at first glance, there's no intersection, right? There's no intersection. So if there's no intersection, Paul, if there's no intersection, how much is this? The probability of D intersection A. How much is that? If the intersection doesn't exist, because again, I am not overlapping or connecting this circle with any of those, if the intersection doesn't exist, how much is the probability of having this?
No hay.
0. Probability is 0. The fact that the intersection doesn't exist is telling us that the intersection is empty. So the probability will be 0. That event cannot happen because the intersection doesn't exist. So what you just found, Paul, was something really, really useful. What you just found was something really, really useful. You gave us our sets, A and D. No. A and B. A and D. A and D are mutually exclusive. Because there is not, the intersection doesn't exist. Sure, there are some other places where the intersection exists. For example, this intersection exists, right? But in this case, the intersection is empty, whatever. In this case, in A and B, the intersection is not even possible to draw, to draw it. I cannot draw it. So the intersection doesn't exist. So the probability is 0.
Profe.
Yes, who's that? Paul again?
Paul, sí.
Yeah, tell me.
Otra pregunta. Cuando yo voy a hacer la anotación, o sea, cuando voy a escribir eso, o sea, que es igual a 0, ¿no sería D y ABC?
No, because mutually, okay, you can say mutually exclusiveness just with couples, right? But there are some books that accept mutually exclusiveness with threesomes and foursomes, right? Groups of 3 or groups of 4. So if you say something like this, D and A, B, C, for
Sí.
example, then you're
Yes.
saying the intersection of the 4. For some books, again, for some books, you're saying the intersection of the 4, right? And that could be a mistake. That
Sí,
could be a
sí, sí.
mistake, right? So we need to name those in couples.
Ah, bueno.
This is one. Another one, B and D. Doesn't really matter the order, right? I can say D,
Okay, okay.
right? I can put it backwards. So I can say D and C, for example. It doesn't really matter the order. But I need to write down the couples. Here it is. A, B, and C. All right. Can we find another couple that is mutually exclusive or not?
Profe, digamos, en la intersección con la intersección de A, B, eso, ese punto. Pero eso,
So
¿qué
you're
sería? O
saying
sea,
you're saying A, B,
en,
C.
sí,
A and B and C, or with ands, right, in the middle.
sí, antes.
And B, and sorry about my handwriting. Sorry about that, guys. It's really hard to write with a mouse. Sorry, guys. This will be correct.
Pero
Okay.
no sería sin el AND en el A y B.
What again? What?
O sea, sin el A, B, ¿no sería?
If you want to put it like that, it's okay. If you want to put it with ands, it's also okay. Why?
Ah, bueno.
Because the and here is used as a connection for A and B. So it's the same as saying A, comma B, right? Now you might be thinking the and is also an intersection, and that will also be correct because you can do this. A intersected with B and C. These two sets are mutually exclusive. We're talking about the circle C and this little piece.
Ah, listo, listo.
All right. Now, the question says that we need to remember, we need to determine which of these 4 are mutually exclusive. So this one is not useful for us in this question. Also, I will not accept this one, the third one, because as I said at the beginning, some books accept mutually exclusiveness in groups of 3 or groups of 4, but usually, and especially for the IB, we only accept mutually exclusiveness in pairs, in couples. So these are the only 3 possibilities. All right? Cool. Now, guys, did you have any questions about this? Yes or no? Did you or did you not?
No.
Right. Cool. Thank you, Paul. I'm assuming the rest don't have any questions. Maybe the rest understood everything, right? So I'm gonna leave you with the rest of the exercises. Don't forget about this, guys. In your free time, we just did 1. We also did 4. We didn't do 2. We didn't do 3. We didn't do this. We didn't. All right? We didn't do these ones. Also, I said at the beginning I was going to use the time to expand on the questions for 7F. So we didn't see these ones, 7E. And these ones, okay, these ones are pretty good. Take a look at this one. If you have the free time, take a look at number 2. It's gonna blow your mind. All right, I'm gonna cut the video here. And we'll continue with some exercises then.